So here's a question from JEE Mains 2024 from the April attempt. A string is wrapped around the rim of a wheel of radius 10 cm and moment of inertia equaling 0.4 kg meter square. Wheel is free to rotate on its axis and it's initially at rest. It is then pulled by a force of 40 Newton. Angular velocity after 10 seconds equals. So what we have here is we are given the radius, the moment of inertia and the force. So what we have here is, we know that the torque acting on a body is going to be equal to force times the radius. It's going to be Fr. So in this case, it's going to be 0.1 into 40. As it's given in centimeters, 0.1 meters is 10 centimeters. So 0.1 to 40 is going to give us 4 newtons. Not 4 newtons, it's going to give us 4 Newton meters. So that's the torque acting on it. Now we also know that torque is the rotation analog of force. Therefore, it is a product of the rotation analog of mass and the rotation analog of acceleration, which gives us torque is equal to I alpha, where I is the moment of inertia given in the question and alpha will be the angular acceleration. So this is equal to 4 is equal to 0.4 times alpha. So alpha clearly here is equal to 4 by 0.4 is equal to 10 radians squared by second. This is the unit for alpha. So now we've got alpha, but they're going to be asking the angular velocity here. Angular velocity can be derived from angular acceleration pretty much the same way normal velocity is derived from normal acceleration. In fact, it's the same kinematics equation, except they replace with their analogous values. So here we have V is equal to U plus AT, which here is going to be omega final is equal to omega initial plus alpha time, and omega initial here is equal to 0 because the wheel was initially at rest. Therefore omega final is equal to alpha time. Therefore it's directly equal to 10 into 10 seconds into 10 radians square by second is equal to 100 radians by second. So that is the final answer. After 10 seconds, it's going to be rotating at 100 radians per second. And in fact, if we want the actual linear velocity too, we can find from this. Linear velocity is always given by radius times omega, which is going to be 100 into 0.1, which is going to be 10 meter per second. Which is not asked in the question, but it normally is. So this is how you relate rotational motion and linear motion, how the analogous values of rotational kinematics as well as linear kinematics are linked with each other. It's a pretty good question to show that.